Studying Earth's atmosphere helps NASA scientists understand how to protect our planet. With data and continuous observation, scientists can monitor and see changes in Earth's climate. NASA scientists measure and study the ozone, aerosols, and water vapor in the stratosphere to enhance our understanding of Earth's climate. The Stratospheric Aerosol and Gas Experiment, or SAGE, is a series of instruments designed by NASA to observe stratospheric ozone, aerosols, and water vapor from space. Over the past 4 decades, the SAGE family of instruments have been critical in making accurate measurements of ozone loss in Earth's atmosphere. The data collected from SAGE-2 helped leaders around the world institute an international treaty banning products containing harmful chemicals that destroy stratospheric ozone. The 1987 Montreal Protocol established regulations around the world that allowed stratospheric ozone to recover over the next several decades. SAGE-3 is the newest and most advanced addition to the SAGE family. It was robotically installed on the outside of the International Space Station, or ISS, and is now taking important measurements of gases and aerosols over 70% of the planet. The SAGE series of instruments takes measurements across the globe using a technique called occultation. Every time the sun or moon rises and sets, SAGE uses the light that passes through the atmosphere to measure gases and particles in that region of the atmosphere. From the ISS, this happens over 30 times per day. High-precision observations of ozone are vital. They demonstrate the effectiveness of the international agreements banning substances harmful to the stratospheric ozone layer, our planet's natural sunscreen. The currently observed trends in stratospheric ozone recovery are very small. An accurate assessment will require continued measurements that are both precise and stable. SAGE-3's solar occultation method provides a measurement of ozone that is inherently very stable and highly precise. It benefits from its predecessor's 40 years of experience with this measurement technique. Aerosols are tiny solid and liquid particles suspended in Earth's atmosphere, such as ash from volcanic eruptions and wildfire smoke. Each day, SAGE aerosol measurements form a visual band around the Earth. Scientists gather the daily measurement bands and create a monthly picture of stratospheric aerosol concentrations. From the southern mid-latitudes through the tropics to the northern mid-latitudes. Arranging the months of aerosol data in order shows scientists how changes in the stratosphere are linked between latitudes and altitudes over the course of months, seasons, years, and decades. SAGE-3 measures the size and amount of stratospheric aerosol particles around the planet. These measurements help scientists better understand how the aerosol particles spread around the planet, if they cause warming or cooling of the atmosphere, and how the chemistry of the stratosphere will react. Within the first 3 years of the mission, SAGE-3 collected high aerosol data on multiple wildfires and volcanic eruptions across the globe. The rotating data plot shows aerosol data measured by the SAGE-3 instrument. The lighter colors indicate a larger quantity of aerosols at various months and altitudes than darker colors. The area below the data that looks like an arch is the tropopause, which sits right below the stratosphere. SAGE data captures the combined effect of fires and volcanic eruptions on the Earth's stratosphere. Wildfires can cause large amounts of aerosols to spread in the atmosphere. SAGE detected the dramatic increase in spread of stratospheric aerosols from the southeastern Australian bushfires. The Rakoki volcano eruption emitted the most sulfur dioxide gas into the atmosphere in the past decade. After the eruption, SAGE-3 detected an enhancement of stratospheric aerosols over the northwest Pacific Ocean. In the following months, SAGE saw the aerosols spread over the entire northern hemisphere. Water vapor is an important greenhouse gas in the atmosphere affecting our planet's climate. Water vapor can be lifted into the stratosphere by extreme storms. From the ISS, SAGE-3 is able to record how year-to-year changes in tropical weather affect the amount of water vapor entering the stratosphere. In the coming decades, ozone recovery and climate variability will be key topics to study. NASA and SAGE will continue to help scientists understand Earth's changing climate, allowing us to better protect our planet.